Ladies and gentlemen, welcome back. If I can please ask for some assistance for the back doors to be closed, just so we have some silence while people talk. Thank you so much. Okay, everyone, welcome back. I hope you had a delicious lunch. And also welcome to our online attendees. Thank you for joining. So our next topic is crucial for optimizing it. Listen to me. Is crucial for optimizing internet network stability. It's all about leveraging the right tools that allows network administrators and engineers to gain insights into network behavior. Everyone makes mistakes, right? So these tools are used to identify potential issues and are there to make more informed decisions. I would like to invite up Max Stuckey, who will be talking to us about monitoring BGP and leveraging the proper tools to better understand routing. Thank you.
Is it? Yeah. Okay. Now it's working. Hello, everyone. I'm back on stage with a slightly different topic. If you followed my presentation earlier, I've already mentioned a couple of the tools, and I think I need to say something else before the slides are going to appear. As a disclaimer, so I've put up together a small list of tools that are useful for day-to-day monitoring, day-to-day, like for checking if you've made any mistakes in BGP. I might have left out something that you maybe use every day, and I would be happy to get to hear about it. Maybe you can come to the microphone at the end and mention if there's any tool I left out, anything that you think would be interesting to add to this presentation. So maybe we can maybe make it in long term a more crowdsourced presentation about what's available there. I think I will skip. I think this doesn't work. There we go. Okay, I will skip the part where, who am I? Yeah, I can see them here. I can see everything here. Again, if you want to know why I'm the owner of the ZANOG Discuss Telegram group, feel free to approach me. It can be a very nice discussion starter for the breaks. But let's get directly into it. Why do you want to monitor things? You want to monitor because you want to understand what's happening around you. It's not only you, it's also how other networks watch or reach your network. Now let's see, there aren't that many people in the room. So let's see, can you raise your hand if you've used a looking glass in the last month or so? Wow, that's a very good number. Okay, so I left out looking glasses from this presentation because I gave them for granted, and that was a good choice. So you want to monitor the correctness of BGP. You want to monitor how your networks are seen by others. You can do it manually. You can use a looking glass, and many of you do. But then what if you had something that could do it for you and send alerts, tell you that there is something going on, tell you that there is something to improve. So, for example, I discovered recently that we forgot to turn off an announcement for one of my prefixes in a special location, and I wasn't sure about that. So monitoring really helps in all this. So before we start with going deep into BGP, I would take a step back. How are your route and Route 6 objects? And for that, there is IRR Explorer. So how many of you have heard about IRR Explorer before? That's way less than people who have used looking glasses in the last month or so. That's good. So IRR Explorer gives you an insight into, so you have your AS number or you have a prefix. How does it look like in the IRR? But not only in your regional registries IRR, but anywhere in the world. So you can see also in which AS sets your ASN is in, and it's useful to also figure out if you forgot to update that. You might have, there is a related work that I've done in the last couple of years. How many networks have objects in different databases for the same network? So imagine if I look into RADB and I see network ABCD has an origin of, I don't know, a certain AS number, and then I look into the Afrinic database and I have a different origin for the same network. Which one do I trust? Which one should I look at? And IRR Explorer helps you look at this data, see this is my report for my AS number, and it tells me that everything is okay except for there is a prefix that were supposed to be originated by another network, 143083 anyway, and that is not good right now. That is actually fine. It was a prefix that I delegated to another organization, and that is good. I know that's legitimate. But imagine you look at this and you have a situation where you discover that some of your prefixes don't have the correct route or Route 6 objects. That could be a potential issue in the long run. Yeah, being included in different AS sets is also an issue in the long run. You see that here there's an overview. For example, my ASN is part of an AS set in APNIC. That's the ISOCLAB AS set, because I used to run that. In RADB, I'm part of the Hurricane Electric AS set, and who is not part of that AS set. But then in RIPE, I'm part of different AS sets for the different exchanges where I appear with my ASN, and for different other organizations. So IRR Explorer, I would consider it the entry point where you start looking at how is your health regarding route objects, but what your routing should look like if everything was done properly. Then the next step would be to use BGP Alerter. BGP Alerter is a tool for monitoring BGP and RPKI, so both of them in one go. It's open source. You can find it on GitHub. Works in real time, and it makes use of data that we'll see later where it comes from. Very easy to use because it has an auto-configuration system, and you don't need to set up any data collection, nothing. You just set up a very simple Linux VM, and with that, you can install it very easily. But what can you monitor? There's actually a long list. I actually like to put this long list because it does not only monitor BGP and RPKI, it also monitors, well, not your BGP and not your RPKI, but it also monitors, for example, the trust anchors for RPKI, so whenever something goes wrong, you also know about it before others do. There's a lot that the BGP Alerter does, and as I said, it's very easy to install and run. When you just do a wget, you get the executable, you run the executable, and then there's an auto configuration, guided configuration that just does it, and you just follow the configuration wizard. So BGP Alerter it was written by a good friend of mine from Massimo. We used to work together at RIPE NCC, and the same person now runs, together with other people, runs PacketViz, which is basically you take BGP Alerter and you make it a hosted version, so you don't have to run it yourself either. So we go into the next stage of this. You have someone else run monitor for you. You can sign up for free. There are different tiers. So there's also a free tier. You start monitoring your ASN directly, and all the notifications are available. So you go to packetviz.com, and the plus you get is that this is run by Italians, so like me. So where does BGP Alerter get most of its data? There's RIPE-RIS. RIPE-RIS, it's a global network run by the RIPE NCC of route collectors. There's about 25 of them, different parts of the world, different exchanges, different colocation facilities. Some of them accept multi-hop BGP sessions. Some others are just tied to the local exchange. You can request to set up a BGP session with it, so you can see then directly what you're announcing to them. Data is available to everyone for free. So you can get an MRT dump, you can get live data. That's what BGP Alerter uses. And you can find more information at ris.ripe.net. Keep in mind, if you go and ask for peering, they might deny that, because at the moment they're trying to figure out, they're trying to get to understand more of what to do with their data. They collect a lot of data, and adding peers in certain locations sometimes doesn't add a value to the data, because they already have too much. So don't feel offended in that case. But you can use it as RIS Live. If you followed my presentation earlier today, the system I used was RIS Live for figuring out if the announcements for my prefix changed over time when I changed my ROAS. RIS Live is very useful. You can subscribe to certain type of messages, and you get data that is already pre-chewed for you, so the next stop, the prefixes included in the message and everything, and then you also get the BGP message encoded in it. And why did I just mention this? Because the limitations of RIS Live is that since they try to keep the messages smaller and short, because they send you a lot of them, they decided to just not implement certain functionalities so far. So you will find out that, for example, in the plain message you get, you don't get large communities. If you want to check large communities, you have to look into the BGP message that's attached into the message you get from RIS. So you will need a parser. You will need to first look into it. If you want a suggestion, and again, if you watched my presentation earlier, I took the effort at one point to say, okay, I need to do this, and I'm pretty sure that there are BGP message parsers out there, but I want to spend a couple of days maybe writing my own. And while I did it, I learned a real lot about how BGP works. I learned a lot more by reading the RFCs, following them, checking the data in the RFCs, and figuring out how things actually work under the hood. So if you work with BGP day in and day out, I would suggest you go and have a look at implementing maybe a very simple BGP message parser. I can provide a list of RFCs to look at, because then the search time is much lower, and that can help. So who else? This doesn't work now. Okay. So who else uses data from RIS Live and the data from RIS? Hurricane Electric. Hurricane Electric has been for years the most well-known source for anything BGP. I remember people quoting it maybe 15 years ago. It still is a very useful resource. You can find out about anything, an ASN's customer cone, its transits, the networks. There is RPKI validation state, the internet exchanges where that network is supposed to be peering, and so on. It's a very valuable resource. But there are also alternatives nowadays. And one of them is bgp.tools. bgp.tools, the image is good where it is. No, it's good. It was. So it's the same as Hurricane Electric, although never quote me by saying that. The concept is the same, but more features are in near real time. And you have a free tier, and you also can pay to get additional services. So you can get notifications when your routing status changes. You can get other additional services, including a remote looking glass, for example. I've seen people who have moved to having a looking glass run by BGP tools. There are certain niche information you can find on BGP tools. For example, the vendor of the device connected to a specific internet exchange, because by looking at the looking glass of or by looking at the neighbor, so the ARP cache, and looking at the MAC address of the device, you can get to the vendor type. Sometimes this can be useful to understand what you have on the other side if you're having issues, if there's another vendor. But those are vanity information that you can find here on BGP tools. Now, tools for your own. I get this. This is basically almost the last slide. There's a long list of libraries, of systems you could use. The one I recommend is BGP-Kit. BGP-Kit gives you all the speed you need, because when you want to look into BGP data, especially when you want to look at what happened, I don't know, 3 days ago, and you take a dump of an MRT dump, and you want to look through it. Sometimes the dumps are millions and millions of records, and then you have all the subsequent BGP updates. So you need speed, and especially when you want to start looking through different collectors, then you want to do it fast. So BGP-Kit brings a lot of speed. It's written in Rust. It's very well maintained. If you send an email to the maintainer, you get a reply usually in a day, mostly in 2 days. And if you request a feature, chances are it will get implemented. So the one I would recommend is BGP-Kit. It also has Python bindings, which is what I mostly care about. I'm not at the level of Rust that I would use BGP-Kit directly. There is the good old BGP stream as well, but it appears as it is unmaintained. There are issues if you want to install the Python PyBGP stream, because it doesn't install on recent versions of Python. My experience has been to move at that point to BGP-Kit for that reason. Then a few last words. Monitor everything. Monitor as much as you can. If you don't see something happening, you cannot act. You cannot do anything if you don't know there's an issue. And the more we all monitor, the more we will understand about where the issues are. People tell me there is, BGP has been there for a long time and everything's fine. There are other things that we still haven't figured out completely. One particular function of BGP Alerter, for example, is to also monitor the RPKI trust anchors. Those are the repositories where you fetch all your data for RPKI. If one of them goes offline, it's not a big deal. All the prefixes covered by ROAs in that database, in that RIR, they will become not found in ROA validation, but that might have an impact on your routing because you send a bunch of BGP updates all in one go, and that might show up in your other monitoring systems where the load on your routers goes up and you have other issues. So having something that also monitors the source of your data can have good implications for you to understand what's happening in the rest of your network. One recommendation that I put as last is manage your notifications. Too many notifications is like none. If you have to dig through what you got to figure out what's happening, then there is a problem somewhere. So make sure you figure out how to reduce the number of notifications to the ones you care about, and then make sure you read them, because then you understand what's happening in your network. And I'm open to questions with this now. I see no questions. Yes, either everyone is bored or being after lunch, you're all still digesting. Well, no question.
Thanks, Max. Next up, I would like to invite Sander Stefan. We will be touching base on the topic automation versus change management. Thank you.
Good afternoon, everybody. So I'm going to change a bit about automation. And this is based on a project I did with a customer a couple of years ago, and the problems that I ran into because I didn't fully think about the consequences of what automation meant for them and for the people who work there and to their workflow. So I hope I can help you with this, so you can make fewer mistakes than I did. Yep. So that's me. I'm from the Netherlands. Started working in the internet industry in '95, starting a small ISP. You know, some modem banks and a small Cisco 2500 router, and the good old days like that. Got a master in computer science. Was the RIPE address policy working group chair for about 11 years. Also one of the founders of the IPv6 Foundation in the Netherlands. Currently one of the founders and board members of the Global NOG Alliance, where we help NOGs and do free web hosting and event management software and whatever we can, basically. Working for SixConnect as a senior engineer, doing everything from helping with software development to automation to you name it. And I'm currently also an NRO NC, which is also the ASO AC, to give two different names to the same thing, member. And that is like an ICANN function where we're actually working on the successor to ICP2, like how to set up an RIR and how to maintain it and stuff like that. So as you can see, I've been doing a lot of different things over the years. So this is the basic advice I give people when we're talking about automation. You don't need to do everything all at once. But it can be really useful to make basic things consistent, like make sure all the host names are set correctly, DNS settings are correct, you use the right radius or LDAP server, like all the basic small things that you just want the same everywhere. Those are really easy targets for automation. So that's usually how it starts. So you have a couple of routers, you make a little playbook to apply some templates. You run the playbook, all the routers get updated, so if you change an IP address of your DNS server, you run Ansible and all your router configurations are updated. So easy, quick success. But then you go a bit further, like, okay, maybe we also configure OSPF and BGP, and of course we're doing prefix lists and filtering, and we start doing ACLs for certain things, for management interfaces, for customers, and your Ansible playbook grows and grows and becomes more encompassing, like everything, not just the basic defaults, but actually it becomes part of your operations workflow. And then, of course, you need to get operations data. So Netbox, Nautobot is a very commonly used tool to store hosts, routers, interfaces, patch cables, everything like that. Peering Manager for BGP sessions and filtering. You may have some internal systems where you pull some data from. And of course, this all goes into Ansible, and Ansible collects it, runs all the different playbooks, and your systems get updated. Really nice, really cool. But at that point, you start running into challenges. Because by now, your playbooks have grown so much, a lot of is going on. So maybe you only want to update the BGP pairs, but not the rest yet, because that's still a different project that's still in progress. So you could break down your playbooks and make smaller playbooks, one for this bit of the config, one for that bit of the config, but then you get things spread out all over the place. Or you can use one big playbook but give tags, so you can say like, okay, run this playbook, but only the BGP bit. I did that for a while. But you also are pulling in all this data from Netbox, Peering Manager, and other sources. What about if while you are running it, your colleague is making changes? Like if you're pulling in the live data, suddenly, if you don't coordinate it properly, then you're already deploying changes that aren't ready yet. So maybe you can break the network like that because they already updated one side but, of a link, but not the other side, so suddenly you're pushing bad configuration. And I've run into that, and the colleague was like, oh yeah, hold on, running Ansible for a bit, I'm still busy, you can run it tomorrow. Well, in a small team, you might get away with that, but you get all these coordination problems, and people become really unhappy. So when you get a situation like this, where you're pulling data from, live data from Netbox, like, are you really sure you still know what's going on? Like for projects where I'm the only main admin, it's fine. I update Netbox, I run Ansible, that's okay. But when you start working in a bigger team, especially when that team is like 10, 20 people large, people are working on different projects in different parts of the network, you really don't know what everybody else is doing, and the chances of accidentally pushing a bad config suddenly become much larger. So that's like undoing the whole benefit of automation. Like you want automation to have everything nice and consistent and predictable. At this point, I was like, yeah, I have no idea what exactly is happening. As long as I stay in control and I tell other people to back off, then I can keep it under control. But the moment people start using this every day in their normal work, it becomes a mess. Now, the colleague I upset the most when I was doing this was the change manager. Because their job was, they got tickets of changes that need to be made to the network, and they would go like, right, so one person is updating this cluster over there, while the other one is working on that fiber optic or backbone, and he just was looking where everything was changing to make sure that you wouldn't accidentally like have one person working on a primary link while the other person was bringing the backup link down. You know, that's way too much risk. So their job was to make sure that all these changes could be done safely. But now we have this automation, and automation is basically, yeah, pull all the stuff from Netbox and deploy it to the routers. But what exactly changed in Netbox? You know, do we actually know if we're in the maintenance window at 3 a.m. in the morning, we're going to run Ansible? Can we predict what's going to happen? And the answer was no. And for the change manager, it was like, basically he was getting 20 tickets that said, oh, I'm going to run Ansible at 3 in the morning. Is that okay? No idea. So this became a problem, and it was actually so bad that I presented I was really proud. I built my automation system, and we had, this was actually for a new Juniper-based core network. We were building all the configs, and I was really proud showing them, like, see, you just go to Netbox, you change the core links, and it will automatically provision everything for you. So, awesome. And then the change manager was, I hate it. Like, this is total crap. I was like, whoa, you know, I was being really proud that I built this cool system, but then he explained these problems to me, and I was like, yeah, it kind of assumes that your data sources are correct, and that nobody accidentally made a mistake somewhere, and that's not realistic. So this is basically what it looked like Netbox, Naudobot, Peering Manager, they're all feeding data straight into Ansible, and then Ansible is deploying that configuration everywhere. So somebody makes a mistake, puts some bad data in, and suddenly you run Ansible and your whole network goes down because there is a stupid conflict somewhere. Like, this luckily didn't happen in my case, but it can happen. So yeah, garbage in is garbage out. If somebody makes a typo, you have a problem. And of course, for a big production network, this is just not acceptable. So went back to the change manager and discussed with them what their job was and what they wanted from it. And the main thing is he can't approve changes when the changes are in flux, when they're coming from live databases. So we needed a system to make a snapshot where we're like, okay, we're going to apply these changes at this point in time, and we needed to be able to predict what effect a change would have. So, like I said, one thing was, when I was just doing it by myself, I was just like, okay, everybody, I'm going to do maintenance tonight. Everybody leave the system alone so it doesn't end up in a weird state. Didn't work. So what I did was add an extra step. So instead of pulling the data into the Ansible playbooks runtime, I actually wrote a script that extracted the data from all the different systems, put them in YAML files, and YAML is the file format that Ansible uses as its source, and then told Ansible to use those files instead of live data. You can actually use Ansible to create YAML. So basically I split the work in two. I had one Ansible playbook that would pull all the data and export it as YAML, and another Ansible playbook that would then take that YAML input and deploy it to the network. To make it easier, I wrote a little plugin so people who were working in Netbox could go like, right, I made some changes, send, and then it would automatically create the export and put it in Git. So we use GitLab, but you can use other systems as well. So what happened is they changed something in Netbox, they created an export in GitLab, it created a new branch, and GitLab has a nice merge request feature where you can see like the old version and the new version side by side. You can see what's changing, and that was already a massive improvement for the change manager, because things didn't just change; they were in a separate branch. He could view a diff, he could see the changes, and then say, okay, this is allowed to be merged. That one is not ready yet. Like, this change can happen tonight. That change can happen tomorrow night. So by putting in that extra step, it was a bit more work, because the workflow got longer, but it gave so much more insight into what was happening that suddenly the team was happy to use the automation. You know, what good is a tool if nobody wants to use it? So this is how it went. Like I said, Change Manager approves it. When it's okay, you merge the change into the main or trunk or whatever you call it. But you also have the advantage that if things go wrong, you can actually undo that merge and go like, okay, deploy the old configuration. Because if you have the same input data, then you also should get the same output data. So at that point, you not only have a verifiable change that you can approve and run when convenient, but you also have a backup. So this way made it a lot easier. And just doing it this way meant that instead of like, it used to be their tickets would have like a list like, we're going to execute these commands at 3 a.m. So somebody would open up their terminal, log into the router, hopefully the right one, sometimes it was the wrong one, copy paste the commands into the router, see if there was an error, do some checks, roll it back. But this was all at 3 a.m. when they just had been sleeping, so not clear-headed. So there was always a risk. Now with this workflow, the change got approved. The only thing the engineer needed to do at 3 a.m. Was actually merge the configuration into the main set and run Ansible, and Ansible would do all the typing for them. And if the Ansible scripts were well written and well tested, most importantly, then you actually had a much smaller risk in the maintenance windows at night. So this worked. Now, of course, I like to play with things, so this wasn't enough for me. I actually went further. So there's a couple of things that still cause issues. Like if you have multiple changes queued up, then it's gonna look weird because you apply one change, but the other change is still referencing the old state. So what you need to do is you need to rebase it. Like we now want to apply this change to the new state. Well, of course, I wrote a script for that to do it automatically. This is called in GitLab, you have CI/CD, continuous integration, continuous deployment, which basically means you can run scripts and run tasks whenever things happen to your Git repository. So it's like, okay, when somebody makes a merge, then all the other changes are now based on the new version instead of the old version. When somebody actually does the merge, so you got the change approved, you click the merge button, it would actually automatically run Ansible. So the moment you click merge in the GitLab interface, you just saw a window open and it was just doing the changes in the background, so you didn't even need to do that manually. What we also did, and this was really easy because it was a Juniper, in Juniper you can push a new configuration, but then not commit it. So in a Cisco, when you're old-style Cisco iOS, every time you type a configuration command, it applies instantly. So, but in Juniper, you can give it a whole new config, and then just say, show me the changes. So instead of looking at the source data that we're putting into it, we could actually see the resulting changes on the other end. So, and I wrote a little script for that, so that it would actually, when somebody created a merge request, it would generate the new configs, push the new configs to the Juniper, do a show diff to see all the resulting changes, then not commit them, don't apply them, just use it as a syntax check and to get the changes, and then the output from the router would be appended to the merge request. So you could actually see like, this is the input data that changed, this is the output configuration changes that will happen because of this, and then the moment you click merge, you knew exactly what was gonna change. And I built that whole set, and like for everybody, this is one of those custom things, like it's not a project you can open source because everybody's workflow is different and companies have different team compositions and requirements. But I found out that this worked really well. It became so easy to just queue up some changes, tell somebody to run them at 3 in the morning. Could have possibly been a cron job if I really wanted to. Another thing I did also was I did a nightly Ansible run that checked for certain things that we didn't want, because obviously people sometimes spot an error and go in and quickly fix it manually, but then then you start automating things, but with all the manual changes it still becomes a mess. So you can also then have recurring tasks that check if anybody made any manual changes and send them an email saying, hey, what are you doing here? So before I go to the next one, the main thing here was that the change manager felt in control again, but also the rest of the network engineers. One of the problems I ran into was that they were like, yeah, but we only get to put something in Netbox and click a button, like the value I feel from doing my job is diminished. I don't have any autonomy. Somebody writes the templates and I just get to execute them. While before, I had enable access on a router and I could do stuff. So this is another thing that is a cultural change and not so much a technical change. In the end, we sold it to the engineers saying like, yes, all the boring stuff that we can automate is now automated, so you have more time to spend on interesting work. And in the end, they accepted that. But when you're doing automation, you're changing the roles of people in your team. And that bit is much more difficult than writing an Ansible script. So, yeah, this is the workflow where we ended up with. We have data, which get put in GitLab. The green person is the change manager who will then approve it. And only when it's approved will it be used by Ansible to deploy to the routers. And this worked remarkably well. So, Ansible bits, the configuration, that's the easy bit. The workflow is where I see most automation projects fail. Now, it's definitely worth it. Like I said, no more midnight typos. People start to use it to know what's happening when. So in the end, people have more visibility and they feel more confident. But it's definitely a process, and yeah, don't underestimate it. Really talk to your team, see which roles are affected and how you can make sure those people still feel in control. Questions? Ooh, Nishal is walking to the microphone. Now I'm scared. Hello.
Hello, my name's Alan. I'm from AS 37199. Can you give us some examples of what goes wrong? When you've taken the network down, what mistakes did you make? Can you share that with us so we don't make the same mistake?
Of course. So I was lucky because this customer was switching from Cisco to Juniper. And we actually had some DWDM wavelengths we weren't using. So we were building this in parallel to the production network. So I was quite safe. But yeah, things that went wrong is, for example, we use the data in Netbox to generate descriptions. Like in Netbox, you see which interface on this side is connected to which interface on that side. So we would we would use that for the description. So the interface would automatically get the description like this interface goes over there. If it had data on which path it took, it even included that in the description. It would also check the OSPF areas based on certain tags. It would do BGP configurations. And what happened is that somebody was in the middle of a change. So something used to be a customer port, but was now becoming a backend port. And they already reconfigured the core router, but they hadn't changed the information in Netbox about the other side of the link. So suddenly the OSPF areas didn't match, and the BGP settings didn't match, and stuff started breaking down all over the place.
Sorry, follow-up question. You mentioned Netbox there. Sorry, can I leave the mic on now? I think just for questions. You mentioned Netbox. We have used Netbox because we thought we had to type in everything manually. Do you have scripts to get things into Netbox and out of Netbox as well?
Of course, I wrote some custom stuff, but yeah, no, it's. I was actually for a while I was a Netbox core dev. I actually helped on the core team there until I had a big falling out with the main developer, and there's another fork of Netbox called Nautobot. They actually build better onboarding tools, so you can have a look at those because the Nautobot.
Spell it?
Can I have the slides back? It's on the slides somewhere.
Nauto, N-A-U-T-O.
Yeah. So, but yeah, because the main developer of Netbox refused to write such tools because he was like, no, my system is the source of information. You're not importing any crap into it. That was a conscious choice back in the day. So, yeah. Anyway, I'll leave the ranting until the beer.
Hi, Graham from the internet. Alan actually stole most of my question. In a scenario where you starting from scratch from a new network, building it up from nothing. It's very easy to document and to build up the documentation and work from there. When you've got an existing network and you're trying to get on that journey to automation, getting the true and clear view of what's actually going on seems to be a big problem. And yes, as you say, onboarding with Autobot is fundamentally handled differently to Netbox. Have you got any other comments on how you get everything in at the beginning, particularly with a network that is still operationally running while you're trying to get up to speed with automation?
So yeah, the bit I developed this for was a new network, so that was easy. But they had, like the data centers were full of Cisco 2950s, 2960s, you know, that era of hardware. And you could actually, when looking at the config, you could make a guess in which year it was configured. Because, you know, the standards moved, but they never went back to the old hardware to update them to the new standards. So like, oh, they configured it here in this way. Oh, so that's a newer switch then. So what we did is use the same system, especially when doing the diffs on the resulting config, because you put it in as the way you think it should be now, and your diff will actually show you, like, if you would run this is what's going to change. So even so you automate it, but you don't actually deploy it yet. You automate it, you compare what's being automated versus what's on the device. That gives you a list of all the old configs and legacy stuff and all the stuff that's out there. And then you have to go through that bit by bit to see, okay, this bit is actually a valid exception to the rule. So this bit we have to do something with. This is just old stuff that actually does need to be replaced by a modern config. So yeah, it's a lot of work. But you can do it incrementally, and you can automate just like, if you start with simple things like make sure the DNS settings are right, the host name is right, the ACLs, radius settings, all that kind of stuff. Even then you'll find lots of things where, for example, one of your radius servers is missing in the config on half the devices, and the other half is missing the other one. So, you know, there's going to be that kind of stuff, because if it's not automated, it's going to deviate. Like if you have a manual process that involves 50 steps, on average, my gut feeling is that everybody performs 48 of them, but there's always the two that are missing are in different places everywhere. So, you know, if you have a network that's been manually configured for a decade or more, there's going to be little bits and pieces everywhere. And yeah, you do have to go over that and clean that up. But if you automate it, and even if you're not automating the deployment, you can at least automate the validation and the checking. But yeah, it's a lot of work.
Hi, Nishal. No hats.
Nice to meet you.
Thanks. That was an interesting talk. I want to move this to the middle because I like it being in the middle. It seems to me, and I'm not an automation expert, that there's something missing here. Right? So you've got what you want the intended config to look like, but surely there should be something that you can test this against. Now, big network operators model their networks, and there are a lot of fantastic, very expensive modeling tools that you can use to do this that cost, you know, more than the wine farm that's next to us. Mm-hmm. But there are also some fantastic developments in newer modeling engines, pieces of software that we can use. I'm not familiar with it, but I know of Container Lab. Are there other such tools that you could suggest to folks that might be useful, and maybe fill that into the timeline that you've built for how to do things?
So there's a couple of them for simulation that are probably quite well known, but you have GNS3 is one of them, where you can drag and drop and build a network and run devices. EVE-NG is another one where you can simulate it. And yes, what we actually did at this customer, we had 2 racks of test equipment, which was, of course, so we had like from every type of box, we had 1 or 2 in the lab. But that's, of course, never enough to simulate a whole network. So what we did is we would test all the automation on the physical boxes first. Then the next step would be we would actually test them connected to a virtual lab that emulated a bit more of the network. And after we tested all of that, then we would move it to production. and even then probably deploy it against 1 or 2 boxes before just saying deploy to everything and run it everywhere.
Okay, right,
So
thanks. That was going to be my next thing, which is why didn't you try it on one of these software, are there gotchas we should be
So
aware?
in this case, we use Juniper. So I used VMX, which is the virtual MX series router. We had 2 or 3 real MXs in the data center, and we would test against the combination of that before going to production.
Hi there, name's Joe. I was wondering if you could share more insight into the politics between Nautabot and this other one. I played with them for a little while, installed both, couldn't really work out what's happening. And I think the one raised more funding, and I was just very confused. My use case was actually a DNS automation, so if you have any insights there.
Yeah, that's an area I haven't done a lot of automation in, so I can't help you there. What I did do with Ansible is just generate config files. I mean, Ansible is really good. You give it a template, and it just merges the data into a text file. And then once the text file is generated, you just run a bind reload or NSD reload or unbound reload or whatever you're doing. So at that point, you're just generating text files, and that can apply to a lot of tasks. No, the thing that why I left Netbox, I'll keep it to my own part of it, is that at this ISP we were doing a lot of DWDM. So I actually wanted to be able to trace from an interface, like from that interface, the cable goes to this patch panel, comes out at that patch panel, then goes into this MUX channel X, which is then on this circuit to this other building, where the DMUX splits it out again, goes through this patch panels to that device. Like we're actually doing the full cable trace between buildings, between devices. And one thing that didn't work in Netbox is if there is a leased line circuit in your path, it would stop the trace there. But I was like, no, I know I'm on this wavelength on this circuit, but I also want to know where it comes out at the other end. So I built the logic for that code multiple times, and the main developer kept breaking it because he didn't consider it a valid use case. And at some point, after it got broken for I don't know how many times, I just gave up and I was like, I'm sorry, but you may not consider this a use case, but there are people relying on this. And his answer was, well, I never said it was a supported use case, so therefore I don't have to care about whether it works or not. I'm simplifying a lot here, but and I'm a bit grumpy about it, so I'm biased. Don't take my word for it. But that's kind of the interaction that went on. Like I had some things that I really wanted supported, and they were just not considered important enough for other developers. And when Nautabot split off, that was actually the old employer of the Netbox developer, and they split it off. The first thing they did was ask me for my changes so they could fix it in their version. So that's why I get along with them better. But again, special use case and very biased person speaking here.
I'm Rish from ISOC. Maybe a question for those who are still hesitating to go into automation. What advice would you give to balance between going into network automation and possibly keeping control on the existing? So is there,
So for existing networks, I would say start with the simple things and just expand from there. Depends on how uniform your operation is as well. Like if you have a small data center and lots of different customers with different requirements, at that point automate the basic things, but every customer configuration is going to be so different that if you want to build templates and processes and workflows for all of them, you're going to spend more time building your workflows than actually running them. So at that point, that's definitely not worth it. If you are looking at, for example, a core network where you really want to make sure that every core router follows a strict standard and is configured in the same way, that's a much better target for automation. And we even had the policy, like we would actually let Ansible just overwrite the whole config. Like it would ignore the current config, just put in the new config, and that was going to be the config. So if people wanted to make manual changes, within 24 hours, those changes would be rolled back because Ansible would have overwritten them. And that was a feature, because we were like, the core net devices need to follow the specs. We don't want any surprises there. And we don't want any custom fiddling with settings on that end. Now, on the side where the customers are connected, where you have lots of different use cases, lots of different things, obviously you need to allow for more flexibility in what people do on the routers. But yeah, that would be my balance. If you can have a part of the network that needs to be super stable, automate everything. If you have a part of the network where you just need to be able to adjust quickly, automate like authentication, ACL, security, those basics, roughly. And I just saw a sign that I'm running out of time, so I guess it's time for me to go.
Thanks, Sander.
Very quick question, Donald Jolly. If I want to learn more about this, how would I go about that?
I completely forgot to mention that. So on Thursday, I'm running a tutorial on automation. I'm going to start real low level, like very, very basics of Ansible, because Ansible is what most people use these days. So it's going to be a very entry-level presentation. No prior skills except a little bit of Linux or BSD command line required. And then, depending on who is attending and how it goes, we can move into more advanced concepts. But yeah, that's going to be on Thursday, the whole day.
Sander. Before we move on to our next topic, this is just a reminder that if you are a peering network, an IXP or a data center, please to send your peering personal slides to prezo@nog.net.za. Next up, we have Jack Klutz, who will be covering the topic, A Brief History of the Internet's Biggest BGP Events. Stretching back to AS7007 leak of 1997, this talk covers the most notable and significant BGP incidents in the history of the Internet, from traffic disrupting leaks to recent crypto stealing hijacks. Using this historical perspective, we explore the questions like what progress has been made and what is the path to finally securing BGP. If I can welcome Jack Klutz to the stage. Thank you.
Yeah. So, hi again. Jacques, I'm with Kentic as a solution engineer, and I'm going to present about the biggest incidents that we've seen on the internet. This is actual work from a colleague of mine. He used to be part of the BTAC group, and he wrote an extensive report about all the incidents that were seen in routing security. There's a blog published on Kentic's website, and it's also being translated in Spanish, but I don't think we have any Spanish people here. So let's go through that history of incidents and why are those incidents problematic? You know, they cause disruptions, they cause services to be not available, just general pain from a lot of users of the internet. The other incident, the other problematic reason is misdirection of traffic, and that might even be more problematic because that will give others the opportunity to inspect your traffic, to maybe see what you are doing, and maybe you were just doing a payment and they now have your payment details and stuff like that. So there's, you know, it has a big impact and has a big effect if that error or that that issue with BGP has happened or is happening. So let's throw through that history. You know, there's a lot of types of incidents. There's a lot of type of the scale of the incidents could be large, and you know, we have the ones that we make the mistake in the configuration and we say, I should never have done this. But it could also be much more difficult to solve and to figure out what exactly happened. So until a few years ago, we could not do a lot about this as well, and that made it even harder to work against those incidents and to prevent those incidents to happen. So when we speak about disruptions, we often talk about leaks, routing leaks. But what is a routing leak? And we have a definition. There's an IETF RFC that, you know, goes into a lot of detail about that definition. But basically it drills down to that a routing leak is the propagation of a routing announcement beyond their intended scope. So somebody is announcing a prefix that should not be announced from that network, or is changing the AS path. So there's there's something in the middle that should not be there. And then we're talking about an origination leak or an adjacency leak. So the origination is a prefix should be advertised from the one network, but is advertised from another network. That's where the origination goes wrong. And the adjacency is when there's a network in the AS path that should not be there. So a couple of examples of those origin leaks and disruption due to leaks, some of the origin leaks. So the AS number that should originate the prefix is not the one that has been seen in the routing table. And that goes back to before I started working in this industry. It took me another 2 years before I came into this world. But in 1997, there was this first major disruption caused by a routing leak or a routing leak. There was a software bug that caused the router to originate a lot of the global routing table. And you know, you can imagine what happens then, that you know, when someone starts announcing all those prefixes with this AS number, all that traffic will be redirected, or at least if you are the preferred route on top of the other routes. And after that, a lot of other similar incidents happened. There's the Turk Telecom leak in 2004. China Telecom did a similar thing in 2010. Telecom Malaysia did a similar thing in 2015, and there's many more. And there's an extensive report, as said, written by Doug Midori, that goes into a lot of detail about these leaks. But they had one thing in common, and that was that they all used their own network ASN as the origin, so they were all attracting traffic to their network. Some of that was intentional, but also accidental. The Pakistan incident, where they tried to stop their citizens watching a particular YouTube video, and I'm not sure why it was a Dutchman, that posted that video, but at least the Pakistani government didn't want their citizens to watch that video. So they ordered Pakistan Telecom to block the traffic to YouTube. But what accidentally happened is that, you know, they created more specific routes. Those routes, you know, they attract the traffic. But what accidentally happened is that those routes were advertised to their upstreams. So that caused not only their own citizens connected to Pakistan Telecom to prevent watching that video, but it caused a lot of other users wanting to reach YouTube to not being able to reach that, because they, you know, routing is following the shortest path and the most specific prefix. So all that traffic was diverted to Pakistan Telecom, which basically rendered that YouTube was not able to, you were not able to reach YouTube in that case. And that happened more. It's not only that accident in Pakistan, but there's also for Twitter that happened a couple of times during the military coups in 2021 in Myanmar, 2022, when there was a Russian thing going on. But there was a slight difference, and that is that Twitter had set up RPKI, and we've been talking about RPKI before today, but they were able to mitigate the incident that was happening just by having set up RPKI. So we talked about a couple of examples for that origin leaks, and then there's the adjacency leaks, where people start ingesting their own network in the AS path, either on purpose to, intercept the traffic or by accident. So there was a leak in November 2018 where Main One passed a couple of routes to their transit providers. China Telecom carried those routes towards the internet, and Google and Cloudflare were among the disrupted networks. In that situation, there were prefixes announced with a path that is not the path that it should be. There was a network involved that should not carry that traffic. Similar thing in June 2019, where about 29,000 routes were leaked from one provider to another. And in this case, it was a route optimizer. An appliance that looks at your traffic and tries to optimize your connectivity, and was trying to optimize your connectivity by advertising a lot more specifics to steer the traffic in the way that it should be. But those prefixes got announced to the global internet, more specifics to the global internet, from a network that should not advertise those. So that network started to receive that traffic, rendering either that network impossible to reach, or any of the users being able to look at the traffic that was there. And Cloudflare was one that took the biggest hit for this one. But the origins were intact, so how do we stop this from happening? How can we make sure that your prefixes are being advertised over the correct AS path from the right origin? How do we do that? So in the media, it is said that the bridging gap protocol is hopeless. And this is how much people know about the internet. If you're on Sky News and people say and start explaining about outages, and they talk about BGP, and then they talk about the bridging gap protocol. I mean, I hope we all understand what's going on here, and that the media sometimes is completely wrong. But anyways, it is BGP that we should look at. And are they right? Is it hopeless? Well, is it hopeless? Are we actually doing a better job? Are we making the same mistakes as ever? Did you ever, configured a routing policy that accidentally leaked a route, yes or no? You've been testing it, maybe you've been automating it, Sander. But has it ever happened to you? So what can we do against this? There are technologies nowadays. There's RPKI, which is, we're making progress there. Those origin leaks, we can prevent those by using RPKI. Set up those ROAs, do the validation, set up your routing policies, and we see in the overview that there's many of those. This one is taken from NIST, where we can actually see how it's evolving, how the deployment of RPKI is evolving, where we see more and more valids. The green line is going up, and less invalid and unknown routes. Sorry, we see less unknown routes in in the routing table, so less routes that are not being covered by a ROA. So that's actually going in the right direction. And a lot of the major tier 1 networks nowadays have set up their routing policy to discard any of the announcement that are validated invalid. So if we look at the statistics, we actually can see that we're really making progress. More and more of the traffic, more and more of the routes, they have ROAs, and we see that the traffic that is being carried over those routes is growing as well. So more and more traffic is being protected by this technology. And if we, that update down here, it's from February, just a couple of days ago, a couple of weeks ago, 50% of the BGP routes now have ROAs, and those take care of about almost 70% of all the traffic that we see on the internet. So is RPKI actually reducing the propagation of invalid routes? Yes, it is. If we look at this graph, I explained it this morning as well. These graphs show the propagation of routes seen from the vantage points from route views. So the more vantage points, so the further on the right in the graph, the more vantage points see a prefix, the further it is propagated. So we can see that the not founds and the valid prefixes, the validated prefixes, that is propagating far over the internet. A lot of the vantage points, almost all of the vantage points, see those prefixes. The invalids, the green graph, there you can actually see that the majority of the prefixes are on the lower end side of the graph. That means that not all the vantage points see those prefixes. So that means that the propagation of those prefixes actually doesn't go as far as the RPKI valids or the RPKI not found prefixes. So that's a good thing. We are taking care of that global routing infrastructure. But it's not just RPKI. There's a lot that we can do to make sure that those incidents that I was describing earlier, that those don't happen. General improvements in your routing hygiene, your documentation in the routing registries, IRR filters, awareness, like the talks that I'm doing, like the talks that have been here today, and there's manners. That's a document, or basically a way of working, a way of operating your network with a lot of common practices, best practices, definitions on how to set up routing, how to set up filtering. It's a document that has been working on for a long time. I know that ISOC started that a couple of years ago. And it's something that's being adopted by more and more networks. That framework of best practices is being adopted by more and more networks. And one good example, for instance, is China Telecom, when we saw those in the incidents earlier. So they are not leaking any routes anymore because of the fact that they joined Manus, so they adhere to all those common practices. Otherwise, you can't join that group of networks that, So it's not just RPKI. So I want things to become common knowledge. We have to make sure that the majority of traffic is directed to RPKI valid routes. And we have to be sure and we have to be aware of the fact that if there are invalid routes, that route propagation is cut in half. So we are doing a good job. We should continue this good job. But that global routing system can be manipulated, and there will always be ways to redirect the internet traffic. We've only been looking at the source of your advertisements, the source, the originating network, and the prefixes coming from that network. So those leaks where we see a network in the middle, there's a lot of documentation, there's a lot of research being done on the misdirection of those communication. So actually hijacks of traffic. There's documentation about those man-in-the-middle attacks, descriptions about attacks and the effects and the things that happened after the attacks, where financial institutions were hit, foreign ministries were hit, and stuff like that. So what do we do against that, instead of being only able to validate that announcement, whether or not it comes from the right origin? What happens when you have that man-in-the-middle attack? How do we stop that? Well, maybe first a good example of that. There is an attack that was there in 2022, Cellerbridge. It is an organization that does cryptocurrency services. You can change one crypto for the other, and they take care of that. And you don't want to be, you don't want to have that there's someone in the middle of that changing your wallet address, for example. So your currency is not being transferred to that other wallet in that other currency, but it's being stolen from you. So how do we stop that? Let's skip to that. Oh, we have an example here. Let's go back one slide. So that Cellerbridge, that service to convert between the cryptocurrency, what they basically did was that redirect of the attacker's wallet, so that any currency that was being converted was being transferred to the attacker's wallet. So that, that's very profitable. But why was this successful? It was successful because a additional AS path was being AS number was being added into the freely available OldDB, which is a routing registry that anyone can use. So they just updated that, added a new AS number. So from a routing perspective, from a routing registry perspective, this AS path was actually okay. This was correct, but that couldn't be seen. So looking at the graph for that traffic, where it looked like the traffic was originated by that Amazon ASN, but that should not be the case. So we can actually see that malicious route was there for a while, and the legit route wasn't there for a while. So they were very, very successful with this. And that because of injecting a different AS number in the path and being that man in the middle. Can we stop these with RPKI? Now, well, they had a ROA for the originating AS number, very liberal ROAs. They used max length, so everything was there. Some prefixes were not, some prefixes were in, some were not, but the most important ones were in there. So can we prevent this? Actually, no, because the origin wasn't the one that was changed. It was the AS path, and we need something else for the AS path. And there is work being done on BGP-SEC, which is a different method to secure your AS, the BGP topology, and the ASs that are advertising or leaking prefixes. So we should be able to do more. We must do more. We have our PKI. We're working on ASPA, where you can define your upstreams that are allowed to advertise your prefixes, so it doesn't look like a leak, because you just tell the system, well, this is a network that is allowed to advertise my prefixes. And there's BGP SEC coming up, where we try to stop that man-in-the-middle attack. So we're moving the needle on routing security. Things are improving, but we're not there yet. We are halfway, and I hope that more and more people start working on this and start implementing the security measures that are out there, and start working on implementing the newer stuff that's coming up. So that's it, and I think there's time for questions.
Open up to the floor. Any questions? Thanks, Jack. Okay, just a bit of an agenda update. Up next we have peering personals, and then we move to a tea break from 4 till 4:30. Thanks. I'm going to hand over to Don. We can call up the peering personals so long. Make your way up on the stage from the left to the right. Sorry. Don. Okay, if you can go to the AV desk, please. Thanks.
NAP Africa and Raxar, you here? Please come to the front. You're up, whoever you are. That's fine. Just that's it.
Hello. There we go. Hi, everyone. I'm Yolandi. I'm from NAP Africa. This is my slide. NAP Africa is an internet exchange point which is available in the Terraco Data Environments facilities. This is in Johannesburg, Cape Town, and Durban. Currently, we have over 640 networks connected and peaking at around 4.2 terabits of traffic. And if you guys want to chat to us, we are around this whole week. And you can, of course, reach out to us at napafrica@terraco or nap@terraco.co.za. That's it. Thanks.
Is Raxar here? Nope, but there you go. There are the details there. We're going to have peering personals tomorrow as well, so please send through your details so that we can slot you in tomorrow. That's it from me.
Thanks, Don. Okay. Let's take a break, and we'll see you back at 4:30. Thank you.